on the use of RMS intensity as a gradient measure of vowel devoicing in Cheyenne. I'll start by outlining the goals of my talk, which are twofold. The first goal is a methodological investigation concerning vowel devoicing, specifically to look into the role of RMS intensity in understanding vowel devoicing. The second goal is a language-specific investigation of vowel devoicing in Cheyenne, and that's an Algonquian language spoken in the US. Specifically, I applied the methodological strategy that I'm investigating to test a claim about a vowel devoicing phenomenon noted in previous literature on Cheyenne. So I'll start now by providing some background, first on vowel devoicing in general, and then on the issue of gradients in acoustic studies of vowel devoicing. Then I'll give some background on Cheyenne phonology. Starting with background on vowel devoicing. This is a common areal feature in the Plains region of North America where Cheyenne is spoken. And it's also tested across a wide range of language families and regions of the world. So even though we often think of voiceless vowels as phonologically marked and typologically rare, they're not actually as uncommon as we might think. There have been a number of acoustic studies of vowel devoicing in various languages, and these studies frequently note gradients in the application of these processes. And this gradience is taken to be a phonetic effect of gestural overlap involving a glottal adduction gesture for a phonologically voiced vowel, and a glottal abduction gesture for an adjacent voiceless consonant. So there's some partial devoicing of the vowel, and the vowel is not phonologically devoiced. Instead, this is a phonetic effect. That's the interpretation of the findings. Typically, however, in these previous studies, voicing is treated as a binary variable. So they take the presence of a voicing bar in a spectrogram, for instance, to reflect categorical voicing, and the absence of a voicing bar to reflect categorical voicelessness. In this way, the gradients as reported in these studies is actually a derived measure based on the proportion of a vowel with categorical voicing or devoicing. Basically, it's like a percentage of a vowel that is categorically devoiced. But I'd like to point out a problem with this approach, which is that voicing cannot be instantly turned off. And therefore, there must be some transition between voicing and voicelessness, during which you should see a different type of gradients, which is in the degree of devoicing. There should be intermediate stages of devoicing, that is. And in terms of glottal gestures, this means that there should be an effect of a glottal abduction or voiceless gesture before voicing completely stops, and that is what drives the transition into voicelessness. And I propose in this talk that a key to understanding these transitions into voicelessness is a measure called RMS intensity. This is basically a measure of loudness, for people who aren't familiar. And in fact, several studies of vowel devoicing in various languages have noticed decreased RMS intensity during voicing in environments adjacent to voiceless segments compared to intensity during other periods of voicing that are not adjacent to voiceless segments. And so I predict in this paper that RMS intensity can provide crucial information about transitions from voicing to voicelessness. And the reason why these previous studies have found decreased RMS intensity in voicing right before voicelessness, for instance, is because there's actually already a transition into voicelessness during that period. If this turns out to be correct, RMS intensity would allow us to identify when devoicing actually begins. So there would be a decrease in intensity during voicing, and that's when the transition to voicelessness begins. In this way, RMS intensity would provide a more nuanced measure of the degree of vowel voicing or devoicing beyond the proportion of the whole vowel that exhibits categorical devoicing. So turning to some background on Cheyenne, this is a Plains Algonquian language spoken in Montana and Oklahoma, which are the two states on the map of the US indicated with the red arrows. Here's the phoneme inventory of the language. You can see that it's relatively small. There are only voiceless obstruents and voiced sonorants. And there's also a pretty small vowel inventory. All of the vowels are underlyingly voiced, and voiceless vowels appear on the surface due to various phonological rules or processes. And I'll be indicating voiceless vowels in this talk with the IPA diacritic, the circle below the vowel. Cheyenne is also a tone language with contrastive high tones, which I'll mark with an acute accent in this talk, and low tones, which I will leave unmarked orthographically. There's extensive vowel devoicing in Cheyenne due to several different processes. And I focus just on one process in this talk because, at least at first, it's important to study the different processes separately in case they involve somewhat different phonetic mechanisms. The process that I focus on targets low-tone vowels before voiceless fricatives within a word. So here you have an example of a word with this with a vowel devoiced by this process. That's the vowel shown in red here. It devoices before a voiceless velar fricative. Crucially, there's a previous claim about Cheyenne, which is that phonemically voiced onsets devoice before voiceless vowels. So this means that the M in the word broom that I just showed you should also be devoiced. And I've indicated that in the second version of the word with the M shown in blue. So the second goal of this talk is to test the claim about onsets. Ultimately, I'll show you that the question of whether onsets devoice is actually not so simple if we consider the possibility of gradient devoicing, but I will also propose a way to understand this previous claim in the context of my paper's findings. Okay, turning to methods. I first want to mention that there are some challenges in investigating the Cheyenne language because it's relatively endangered, and there are significant ethical issues in doing fieldwork with indigenous communities in North America. We can't simply go into a community and collect phonetic data for our own purposes and then leave because of the ethical issues. So for this reason, I make use of pre-existing recordings from a publicly available source in the study. Specifically, I used words produced in isolation in an online Cheyenne dictionary. Because the data is limited and it's difficult to control for relevant contexts, I present data from just 6 words in this talk as an initial exploratory investigation. However, you'll see that there is a good deal of consistency across these 6 words. Specifically, I looked at 6 words with voiceless vowels followed by an S and preceded by a phonemically voiced onset so that we can test whether the onsets do in fact devoice before voiceless vowels. The voiceless vowels are also all in a non-initial syllable, which allows us to observe any effects of devoicing that begin before the vowel, and also to draw comparisons with a voiced vowel in the preceding syllable. You can see the word list I used on this slide. Some words contain multiple voiceless vowels, so the ones that I measured are shown in red. And you can also, I'll just mention, notice that many of these words are quite long, and this is because Cheyenne is a polysynthetic language. There's a lot of morphology. I just wanted to mention that because the length of the words is quite striking, and you can see that some correspond to an English sentence. In all of these words, I identified categorical voicing based on the presence of glottal pulses and prot. Here's an example of how this worked. So you have a spectrogram and waveform here with glottal pulses shown as blue lines on top of the waveform. And the first here in the text grid indicates categorical voicing or voicelessness based on the presence or absence of glottal pulses during that interval. And this is comparable to the binary classification of voicing seen in many previous studies. I then calculated the RMS intensity across sequences of a voiced vowel, onset consonant, and voiceless vowel in each of the words. And this was divided into 3 regions that I focused on. The first region is the voiced vowel and the syllable immediately preceding the devoiced one. The second region is the onset of the devoiced vowel, and I split this region into 2 when necessary. So the first is the portion of the onset with glottal pulses, if there's some voicing during the onset. And the second is the portion without glottal pulses if there's also some voicelessness during the onset. And the third main region was the devoiced vowel itself. And I just want to point out and remind you that it was important to include the regions before the voiceless vowel because that allows us to test the claim about devoiced onsets before voiceless vowels in Cheyenne. Turning to results. First, a summary of what we found with the voiceless vowels. All of the voiceless vowels in all 6 words were completely devoiced, so there were no glottal pulses during any of the vowels. And they also exhibited relatively low intensity compared to intensity in the other regions that I measured. In terms of what we see with the preceding onsets, in 5 out of 6 words, there's voicing present throughout almost all of the onset. And interestingly, these were all nasal onsets. In one word, the voicing stops towards the beginning of the onset, and this was the only onset that was a V rather than a nasal. And it's actually possible that this phoneme behaves differently than other voiced onsets or other voiced phonemes. So it's been noted in previous literature on Cheyenne that V exhibits substantial variability throughout the language, surfacing as different fricatives as well as an approximant. So this is something that I plan to investigate more in the future. But for now, we can say that at least for the nasal onsets, there's a very consistent pattern in which there's really no devoicing in nasal onsets before voiceless vowels. Turning to the results for the trajectory of RMS intensity across the regions I measured. In all of the words, it starts high during the voiced vowel and then falls across the rest of the voicing interval, reaching a minimum roughly when glottal pulses stop. And so this suggests that decreased intensity does correspond to a transition into voicelessness. Now you can see an example of the dominant pattern seen in 5 of the 6 words that I looked at. So what you have here is a waveform with RMS intensity plotted over it in various colors corresponding to the different intervals. There are also 2 black vertical lines which mark the beginning of the onset and the beginning of the vowel. That's here and here. The purple points on the plot are the RMS intensity measurements during the preceding voiced vowel. The orange points are the RMS intensity measurements during the voiced portion of the M onset. The yellow are the RMS intensity measurements during the very short voiceless portion of the M onset. And the green is the voiceless A. So starting with some observations about voicing, you can see here that the voiced interval of the M onset spans most of the consonant. That is, most of the space between the 2 vertical lines is orange. Then voicing stops right before the end of the onset, and there's a very short portion of yellow. That indicates the short interval of voicelessness. Turning to observations about RMS intensity, you can see that it starts high and then falls all the way until voicing stops, where it reaches a minimum. And this indicates that falling intensity reflects a transition into voicelessness, as I mentioned when I summarized the results a minute ago. I would also like to point out, though, that there's an alternative interpretation of the falling RMS intensity preceding the devoiced vowel, which is that it's actually due to something other than the transition in voicing. So one possibility is that the falling RMS intensity is actually due to independent properties of the onsets. This could be the oral closure or constriction for all of the onsets, or the velum lowering for the nasal onsets, since in the word that we've just looked at, the relevant onset is an M. So to evaluate this alternative, we have the same plot from before, but with RMS intensity also plotted for the N before the voiced vowel in the preceding syllable. That's shown in red here. And you can see that while intensity does change a bit during this onset, it remains substantially higher than the intensity during the nasal preceding the voiceless vowel. That's the orange and yellow over here. And this indicates that the low intensity closer to the voiceless vowel, that is in the orange and yellow region, that indicates that this intensity is not simply low due to properties of the nasal stop articulation itself. Otherwise, we would expect to see low RMS intensity also during the N onset before the voiced A vowel. So this means that we can interpret the low intensity as an effect of a transition in voicing. Okay, now you can see the one word in which a V onset devoices before the voiceless vowel. This word is actually quite long, so I'm just showing a portion of it in the figure. Like in the first plot, the different colors of dots reflect different intervals, and the black lines mark the beginning and end of the onset. In this plot, almost all of the onset is voiceless, which is the yellow portion. But like in the other plot, and actually the pattern seen in all 6 words, the intensity falls, that's in the shape of the dots, up until the period where voicing ends, or the point where voicing ends, excuse me. So this indicates that even though the timing of devoicing is somewhat different in this word, devoicing happens earlier, that is, the relationship between RMS intensity and devoicing is basically the same. It falls up until voicing stops. So to conclude, there were 2 main goals of this study, and therefore there are 2 main findings. And the first concerns the relationship between RMS intensity and devoicing. So we saw that there's a large decrease in intensity during the period toward the end of a voicing interval, and that intensity reaches a minimum when voicing stops. And this indicates that a continuous measure of RMS intensity does serve to identify intermediate stages of devoicing. And I therefore propose that this measure provides a more nuanced view of gradients in vowel devoicing beyond the more common binary description of voiced or voiceless, because even when there's something that's categorically voiced, we see a transition reflected in RMS intensity. The second goal of the study was to learn more about the specific patterns of vowel devoicing in Cheyenne. So I will now summarize the relevant findings concerning that goal and propose some interpretations of them. First, we saw that devoiced vowels are categorically voiceless, with voicing ending sometime before the vowel starts. And I propose that this reflects a categorical change in the voicing specification or glottal target of the vowel as the result of a phonological rule or process. This is in contrast to the other possibility, which is often discussed in other literature on vowel devoicing, which is that devoicing is a phonetic effect of gestural overlap. We also saw that at least the nasal onsets remain voiced, but with decreased intensity during most of the onset interval. And I propose that this reflects a transition between voicing and voicelessness due to gestural overlap between a voicing gesture of the nasal onset and a voiceless gesture of a phonologically devoiced vowel. And in fact, I think that this leads us to an interesting extension of these findings, which is that changes in RMS intensity can make predictions about the timing of articulatory gestures that could be tested with further articulatory studies. So when we see that RMS intensity starts to fall, we can identify that, we can make a prediction that that reflects the beginning of a glottal abduction or voiceless gesture, and then we test that with articulatory studies. Concerning how these findings fit in with previous work on Cheyenne, actually the present findings do not support the impressionistic description in earlier work which says that voiced onsets devoice before voiceless vowels, because we saw that nasal onsets do not devoice before voiceless vowels. And I'd like to suggest that this discrepancy between my findings and the previous literature is actually really interesting in terms of its implications for the role of RMS intensity. So I'd like to propose that perhaps the previous observation of devoiced onsets was actually based on decreased intensity during the onsets rather than categorical voicelessness. And this would suggest that perceptible effects of devoicing are present before voicing completely stops. This effect would be missed by a binary classification of voiced versus voiceless. However, we can see it with a more continuous acoustic measure of RMS intensity. So this reflects the important role of more continuous measures of the degree of voicing. Thank you.
Thank you very much for your presentation.
Thank you.
Any questions?
Yes, please.
Right.
I would like, if there is no somebody else.
Sure, Mr. Potini.
Okay, hi. Very, very nice to hear all this. Very interesting. Well, I would say a few things because I really liked your presentation. Well, you have to remember basic principles. Like Martinet used to say, or Martinet, the economy principle, and Malber, the laziness principle. We are lazy, which means if we have two voiced sounds and in between a voiceless, we turn it voiced or the opposite because we can't put effort and adjust our vocal folds all the time, right? The second thing you have to consider is it is a matter of assimilation. And the way I've seen it is backward assimilation, not forward, or maybe both ways. You have to check this. What I saw from your material is that it crosses syllable boundaries, because in many cases, at syllable boundaries, we are resetting. So you have to consider those things. Well, and then how is it duration? Because phonologically, we may say it's a binary feature. It's a vowel, it's voiced. Voiceless may mean nothing, because we've seen it, for instance, in Greek, and not only, you have consonants, stop consonants, you have the real distinction, voiced, voiceless, but sometimes it is not realized through vocal fold vibration, because they are both voiceless, but by length. So the one which longer, you perceive it as voiceless, and the other, so length, duration is a correlate of voiced and voiced. So you have a lot of things to investigate. And then my final point is that I assume that voiceless vowels and voiced vowels, they are not distinctive, which means it's nothing. It's phonetic, which has to do with those conditions I've just named, and even more.
Okay, so, okay, there were a bunch of points to respond to, so maybe I'll go starting with your most recent point. So yes, voiceless and voicing is not contrastive in vowels, but I don't think that means that it's phonetic, because you can have phonological rules that result in non-contrastive allophones on the surface, and there's still a difference between the result of a phonological rule and the result of a phonetic rule. So I would still say that vowel devoicing is a phonological rule, even though there's not an underlying contrast between voiced and voiceless vowels. Then in terms of the length, I think that's interesting. I think that there are a lot of interesting things to look at concerning length and voicing in vowels. The length of the voiceless vowels themselves does seem to vary a lot. In some cases, it's pretty reduced durationally, and I didn't look at those just because it's difficult to get reliable measures of intensity during those. But there are also cases where the devoiced vowels don't seem that much shorter than voiced vowels. But I'd need more data to be able to do a statistical analysis of this. But I think that that's an interesting point as well. Concerning your observations about the direction of assimilation and the syllable structure, yes, both of those were spot on. So you only have, there's a number of devoicing processes in Cheyenne, as I mentioned at the beginning, and they all depend on the context to the right of the vowel. So they're conditioned by slightly different environments, but all of them make reference to the environment on the right. So it does seem like it's assimilating always to the thing on the right. And then concerning syllable boundaries, yes, it can span syllable boundaries, and it seems like the domain of this devoicing process, at least, is the word. So it doesn't have to make reference to any smaller units like the syllable, which I also think is interesting for implications, like in terms of gestural overlap and things like that, which I think are supposed to be more restricted to the syllable. Yeah, I hope I addressed all of those points. Thank you. They were very interesting.
Well, thank you very much indeed. Thank you.
Thank you.